Hello students, this is a brief video that will address how to judge, if given a measurement, how many significant figures that measurement has. Whenever we're looking at a number, we need to diagnose these type of numbers. Is the number a non-zero? If it is zero, is it leading, captive, or trailing? And then does it fall into the category of being an exact number? So to lead us through some examples, I have some measurements. This measurement would have 4 significant figures. Now, why? Each of these values are non-zero numbers, so each of them count as a significant figure. We would say this value has been measured to the 100th of a kilometer. This value has 3 significant figures. Why? Well, I have my non-zero integers, but these zeros are called leading. They never count as being a significant figure. They're simply seen as placeholders. This zero is captive. We call it captive because it's between 2 non-zero numbers, and it does count as a significant figure always. So there's where I get my sig figs. Now, why do leading never count as significant? I could easily write this value to be in scientific notation, and I would never miss those zeros. All right, what about this? Well, I have my non-zero numbers. I have my captive, I have my leading, which do not count. So far, I have 4 significant figures. Now, what about this last one? Well, this zero is what we call trailing. Trailing come after a non-zero number. It doesn't matter if it's before or after the decimal place. Is it after a non-zero number? Trailing zeros are sometimes significant. What makes it significant is if there is a decimal place anywhere in the value. There is, so that makes that a significant figure. So this has 5 significant figures. Well, what about this number? Non-zero, captive, non-zero, trailing. Is there a decimal? Yep. So this has 4 significant figures. When I have a number in scientific notation, I only need to consult my coefficient. However many sig figs the coefficient has is how many significant figures the value will have when expanded. All right, what about this? Negative 40 degrees Celsius. Non-zero, this is trailing. No decimal place. This has 1 significant figure. Well, what about this? Non-zero, non-zero, trailing. There's a decimal. 4 significant figures. One more. What if we would have the value of 100, let's say, grams? Okay, non-zero. All of these are trailing. Is there a decimal? Yes. So it does not matter if these zeros are before or after the decimal place. Are they after a non-zero number? So this would have 5 significant figures. Each of these trailing zeros counts as being significant. Okay, so what about this category of exact? Exact numbers are either defined relationships, like there's 100 centimeters in 1 meter. Well, that is a definition. There are 60 seconds in 1 minute. Actually, this is really 60.00000 equals 1.00 and on forever. We've established this relationship. So these have an infinite number of significant figures. Counted values, not measured. I have 1 red pen. I have 10 fingers. I didn't measure, I counted. You can't be any more exact than counted values. These also have an infinite number of significant figures. All right, so hopefully that gives us a good refresher or general teaching about how to establish the number of significant figures in a measurement.